I am talking about the Crystal programming language, and specifically just a little window of like what a use case for it could be in making command line interface applications with it. I'm going to do a little poll here just so I know the room. Who here writes Ruby code? Okay. Anyone write scripts with their Ruby code currently? Ooh, smaller. Yes. Okay. Well, maybe this will be enlightening. This first segment is going to seem a little unrelated, but you'll have to bear with me. And to those of you that do write scripts with Ruby, it's going to hit home pretty hard. I wouldn't normally plug another talk during a talk, but there's a talk by this handsome devil over here about command line applications in Ruby, the good stuff, from SD Ruby. And this talk is kind of building onto things I've learned since I did that talk, but it goes more in depth into like Unix philosophy and why you would want to do it and how to do that, how to write command line interface applications. I don't really touch on that, so if you would like more information about that kind of stuff, go ahead and watch that. So why not just use Ruby? We all like Ruby, right? So why not just rewind and play that previous talk where I talk about writing command line interface applications in Ruby? Because there are drawbacks, especially when you try to distribute those scripts. Distribution of Ruby applications is very tricky if they're standalone. There's a couple drawbacks. First of all, like the version managers that everyone uses when they work in a Ruby environment all the time will become a real detriment real quick. You'll try to use your awesome log parser in one of your development applications and then switch to another one, and then your super awesome log parser won't be there. Well, why isn't there? Well, because you probably distributed it as a gem and it's not installed in that version, or differently, it depends on some language feature that isn't available in a different version of Ruby that you just switched to use that application. So some of that about language features can be fixed if you distribute as a gem, but then you have a real problem because gems are the most convenient way to install Ruby applications, but we're going to have a little intervention here. If it's a standalone application and it has nothing to do with a Rails app or isn't a library, do not put it in a gem file because you'll run into all kinds of problems and like dependencies will clash. But Ruby developers, and I speak as one myself, we love to put things in gem files. It's like what we do. We're like, hey, Bob, did you get this new thing? Yeah, did you put it in the gem file? I don't know. Yeah, I put it in the gem file. Where do we put that? Put it in the gem file. Sure, that's where it goes, right? It's a gem, it goes in the gem file. But then that just leads to things like you'll see, I just pulled these out of two GitHub repos that I visited recently. One is for an application slanger, and the bottom one is for Foreman. And basically, it's open source maintainers pleading with people not to put their applications in the gem file. And both of those are in the README, and they're born out of what could only imagine were dozens of GitHub issues filed against various problems because of the tool being included in a gem file. So let me propose another way. This will bring us to Crystal. So what is Crystal? Crystal is a programming language that resembles Ruby, but it compiles to native code, tries to be more efficient, and because of that, because it compiles to native code, you lose some of the dynamic aspects of Ruby, a lot of the meta-programming aspects. But it has some cool features. The syntax is Ruby inspired. A little bit different than like a different interpreter of Ruby. It's not JRuby. It's not Ruby implemented with a different interpreter. It is a different programming language, but the language is very heavily inspired by Ruby. It's statically type checked. You can call C code by writing bindings to it. Super easy. If you've ever tried to do that in Ruby, it can be kind of painful. And you'll see later on, it's really easy in Crystal. And it's kind of nice because you have a compiler. So you make mistakes, or you want to optimize the runtime that you're building, the tool that you're building. You'll get real feedback from the compiler. It compiles to efficient native code that just ties into having a compiler. And the bottom one's kind of important. It's self-hosted. So self-hosted just means that the compiler for Crystal is written in Crystal, which is kind of cool because if you understand Crystal, then you can work on the compiler. If you ever heard Matt's talk at a Ruby event or anything, he'll always describe himself as a C programmer because that's what he does. He writes C all day because his interpreter for Ruby is C. Well, Crystal's compiler is in Crystal. So as long as you know that, it should make it a little easier to get around. Let's look at some syntax examples. It should look pretty familiar, right? You got your puts. There's some addition there. You get out an int. The bottom is kind of interesting. It shows that there's S. S is a string. Hinting at what's to come a little bit sooner, the type checking. This is a HTTP server. It looks exactly like what you would write if you were writing the same thing in Ruby. So that being said, it is a lot like Ruby. Here is something that I'll bring out a little bit later. It is my beloved hollerizer, and this tool. There's a Crystal version and a Ruby version, and you look in there. If you squint, if you catch it quick enough, you can see the difference. There's only 2 of them on the whole thing, and I just found that out by accident. I just took it. I took my Ruby code. I took the actual Ruby file and tried to compile it with Crystal, and I got a couple errors, made a couple changes, and I was able to compile the actual Ruby file into the Crystal binary with a couple changes. So, there are differences, though. It's not the same language. So we're going to look at a couple of them right now. Types. You got all the types that you would, all the available literal types. I'm not going to go into all of them because we're kind of time constrained, but you can specifically require an input to a method to be a specific type, or you could kind of lean on the compiler to do that for you, because it does pretty good, type inference. You don't have to specify everything if you don't want to. That's how you can take something and take a Ruby script and compile it with Crystal, usually with minor changes, because it's able to do that type inference for you. It gives you some examples. Like here you can see A is an int. That's true. It's not a string. It is a number. Number is a type. Int is more specific than number. The bottom one is interesting because it's not saying that 1 is a string. It's saying that there's things in Crystal called union types. And a union type is just what it sounds like. It's the commonality between 2 different types. And so this is saying that 1 is a union of int32 and string would include 1, basically, is what it's saying. And union types are very important to Crystal. That is one like a core feature. That's how the type inference works so well, because the compiler will go through and look at each way a variable is used and what its possible types could be, and then try to create a union type for it. Here's another example. So this is a class of, this is an array that includes a string and 2 ints. And if you were to inspect it, you would see that it is in fact a class type array, but it is a union. It can be comprised of a union of int32s and strings. This is another example of how the compiler looks at things. It's going to go through the code, and it's going to go, okay, the A could be 1 in this case, or if this condition is met, it could be a string. So I'm going to go ahead and try to make that a union between the two. And that's not always perfect, because if you went through and tried to, if you used more types than just 2, if you got in there and you were doing a bunch and you had 3, 4, 5 different types, then maybe a union isn't a union type is not what you really want. And that brings us to another differentiating feature between Ruby and Crystal, which is generics, which is something you would see in other programming languages, but it's kind of cool how it's implemented in Crystal. For this, we got a class, myBox, with that just sets a value, and you go through and you try to call absolute on it or size. And while going through the previous examples, that might look like it would work because it's going to guess that it's either a 1 or a string. The problem is abs isn't a method for string. It's not within the union of those 2 types. It's not a common method for those 2 particular types. So you're going to get a compile error down at the bottom, undefined method abs for string. So how you would write that so that you could not have to worry about setting the specific type is using something called a generic. And this is saying same class, and basically it's saying whatever comes in the initialize, the value is set to type T. T is just a placeholder for the particular type of the item you pass into it. So you can see that with box at the bottom, we pass in an int. Int responds to ABS, so everything's happy. And the bottom method, it responds to size, so everything's fine. So basically, if you use that generic type, you can kind of alleviate a lot of the pain of dealing with those, potential pain with dealing with. Usually union types are going to be perfectly fine, and they're going to save you a bunch of time and a bunch of pain. But writing code like this is a little bit more specific and can get around some tricky situations. A really cool thing that you'll see in Crystal that that doesn't exist in Ruby is called method overloading. As you can see in my class there, increment, I have 2 different increment methods. One is just like a increment by 1, and one is an increment by whatever amount you pass to it. So this allows you to compose the class in a pretty simple way. If you were to write that same code in Ruby, you would have to check the amount coming in, see whether it's nil or 0, then increment by 1 if it was nil or 0, or increment by whatever it is if it isn't nil or 0 and is still an int. This, you can do it in two one-liners and looks pretty clean. This is the output, so you can see same method, 2 different things being passed in. One is just increment, one is increment 5, and you can see it increments by the appropriate amount. That was kind of like a minor note when I was reading through the docs of Crystal, but it ended up being really useful in almost every little script I've written so far. There are a lot of other goodies that you could go into about Crystal. You could give a 30-minute talk on just the Crystal programming language, but we're not going to do that because we want to look at some specifics that might be useful to you if you were writing a CLI app. So let's look at a couple of the little specific tools. One is option parser. If you're familiar with Ruby, then you're probably already familiar with option parser, but it's built into the standard library. It's in the standard library of Crystal, and it's super cool. You can see with this code, basically, this is the hollerizer again. We set the banner with the particular usage. You can call on and set it a flag, and then pass a block, and then that block gets executed if that flag is entered by the user during runtime. And then the last one is help, and you'll do that, and that'll print the entire parser block, which will include all of the usage information. So it's a handy way to write really good, help for the user without having to put too much time into it. The next block down, it basically listens on standard in. That's what argf is. It listens on standard in. If it's verbose, it gives a little bit more verbose answer. If not, then it just spits out the line with what we want attached to it, in this case, holler. So that is option parser, and it's really useful. I would recommend using that, or at least trying it out in your next project. Colorize I use a lot too, because during deploy scripts and whatnot, it's always useful to give the user immediate feedback via color. Plus, you can give feedback in color and not break any sort of Unix type functionality of the application. So you can pass something out that indicates an error state and give it the appropriate error code, and then still only have it take one line of output. So if you pipe it to something else, you're not breaking anything else, which is useful, because normally error states you would like throw up error, 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 or something like that, and it would take multiple lines, and then if someone was piping that, it would blow up because they're not expecting that state. I know I've done that 100 times. So it's useful, it's super easy, and that's colorize. The other thing is custom C bindings. So if you've never written a custom C binding in Ruby, not many people do, because it is kind of hard to do. You might not appreciate how easy this is, but this is really, really easy in Crystal. All you have to do is just link to the C library. In this case, it's readline. Then we're specifying the lib. In this case, lib readline. We're just naming it whatever. And then we pass a pointer, okay? And then by calling readline, that's going to open up, that's going to prompt the user for information, and then store it in that pointer. And then we're passing that back in Crystal land to string. That's why we have to cast it as a string there. So we're basically converting that pointer into a string. And then it prints out, yes. So the bottom there you see is like the example usage. I would, a lot of the C standard library is already included in Crystal, like the entire thing already is. So you don't necessarily need to do it for that, but there are all kinds of cool C libraries that you might just want to lean on a little bit when writing your application, and it's pretty easy. Here are some resources. These are just basically go read the docs. The docs are super good, and there isn't really any place to find better information currently than crystallang.org. It's a pretty young language, so it's still in alpha. So it's not applicable to write your next big production server in, but for small command line applications, it's fantastic. Let's see if I can break out of here and then put up terminal. Success. We can show. So so we can list out this private to. This was that little code that I showed you, my example, the hollerized. Oh, wait. Sorry. It's in the Ruby. It's so it just appends holler onto it. And if you're really, we can check the time on this. Let's see. Man, it's pretty fast, but we can also go to. Let's see. That's it. Oh. Staying behind the podium is challenging when you're trying to read the. Oh, I know why. Code. There you go, 17. So 0.6 of a second down to 17. It is faster. It's much faster. That's not even compiled with the release flag or anything. That's just done. So you'll just about any task or script that you would want to write. If you can easily port it to Crystal, you're gonna reap immediate benefits. One of which being that it's just going to be easier to distribute. You can create a homebrew repo for it or recipe or formula for it, and then distribute that, or just send the binary around. In either case, it's going to be much easier than in a Ruby shop. It's going to be much easier than trying to distribute a gem. A gem will be easy to download, but you'll run into problems later on supporting users. So with that, let's see. I will open it up to questions, if there are any.
We have a mic for questions. Just so everyone who's tuning in for the live stream can hear your question and the answer instead of just the answer to no question.
Cool. I'll be the YouTube in the crowd. Is Crystal good for anything other than command line applications?
Yeah, I mean it is good for servers and plumbing applications, log parsers, things that you might use. A lot of things you might use Go for can be done in Crystal. The only difference between the two is Go is much more mature and has hit 1.0. Crystal has not. It is still relatively immature.
I mean, would you write a game or anything with it? I mean, it was a replacement for C in some senses.
Yeah, I mean, you could. You can since you can link to any C library. It interops, so you could. I mean, I've got a couple different projects I'm working on currently with it. Ooh. Most of them are API clients, but that's just due to what I'm working on right now. But it's pretty exciting tech.
Cool.
So you said it was in the same likeness as Go. I'm curious, does it have its own flavor towards concurrency? Or
it supports channels.
Oh, okay, just like
so Go channels. Yeah, okay. It adopted the same concurrency model. I didn't go into that because that could be a whole nother talk. But yeah, currently Crystal includes channel type.
Is there any real reason why you think they went for creating their own language versus using something like Go or Rust? Given the fact that there's this is kind of the trend right now where people are building their own compile down to binary type languages.
I can't speak for why they created it. Why it's appealing to someone like me as opposed to someone who has used Go previously is that I work a lot in Ruby, so there's less context switching in my brain when I write Crystal, and it really boils down to that. It's like the syntax feels so homey when you're just in it that when I go to write some Go code, it's definitely a context switch from the Ruby that I was just writing, whereas this doesn't feel the same. And given if you're doing something with low stakes, currently because it's alpha, then why not give it a try? It's fun.
Are we good? Oh wait, one more question right here.
I got it. Thanks. What's the kind of like package manager story with Crystal? Is this like a Ruby Gem style thing, or is it?
It uses something called shards, and it's a YAML file. So you'll use you would outline what dependency you wanted to get. I believe it supports GitHub natively right now in that YAML file, and then let's see. Here we go. Is it over here? You can do Crystal. And then depths, Crystal depths, and it'll go get those dependencies, install them as libraries, libs in your Crystal app, and then when you compile them, they'll compile in. So you have no external. So your runtime has no external dependencies, which is neat.
Cool. Give it up for Mark, everybody. Great talk.